So for the exoplanet Kepler 10b, which is the closest planet that orbits the star Kepler 10, according to information on the internet, the mass of that planet, it was the very first of the Earth-like exoplanets discovered. It says that the mass of that planet is 3.72 times the mass of the Earth. And the mass of the Earth, as we calculated in our last video, is 5.942 times 10 to the 24th kilograms. So we'll do that, 3.72 times 5.942 exp24 equals 2.21 times 10 to the 25th power kilograms. Now that same internet source says that the radius of that exoplanet is 1.47 multiplied by the radius of Earth. So that's 1.47 multiplied by 6.356 times 10 to the 6th meters. That's what we used as the radius of the Earth in our last video. So we'll multiply those, 1.47 times 6.356 exp6, and we get 9.343 times 10 to the 6th meters. So we converted that number, which was 9,343,320. We rounded it off and we called it 9.343 times 10 to the 6th meters and moved the decimal point 6 places to the left. Okay, so we've got the mass and the radius. So let's calculate the acceleration due to gravity on this exoplanet, on the surface of the exoplanet. The acceleration due to gravity equation was lowercase g, the acceleration due to gravity, is capital G times the mass of the planet divided by the square of the radius. So we know capital G is 6.67 times 10 to the negative 11. And we just calculated that the mass of this exoplanet is 2.21 times 10 to the 25th kilograms. And then we're going to divide that by the square of the radius. And that was 9.343 times 10 to the 6th power squared. So on our calculator, the first thing I would like to do is square the radius of the exoplanet. So we have 9.343 exponent 6, and we're going to square that. Now we see that that's in the denominator of the fraction, so we can do something cool here. What we're going to do on this particular calculator is we're going to use the reciprocal key. And we're going to take the quantity that we just calculated in the denominator and we're going to reciprocate it and put it in the numerator. So we go shift 1 over x. So we just took that and put it in the numerator. So now we're going to multiply that by the quantities in the numerator, which are 6.67 exp negative 11. And then we're going to multiply that by 2.21 exp25, and that gives us an acceleration due to gravity of, it looks like, about 16.9 meters per second squared. Okay, and that's good to know. That's the acceleration on Kepler 10b, the acceleration due to gravity. Now the acceleration due to gravity on Earth, as we recall, is 9.81 meters per second squared. And that means that the acceleration due to gravity is almost 2 times as much as the acceleration due to gravity here on the surface of the Earth. And we'll come back and talk about some of the consequences of that in a moment.